All right. Hi, everybody. Good morning. I wanted to check back in today for the Aquapod launcher and kind of the family game night questions that I've been receiving. Some of the questions that I've gotten and some of the things that I've been seeing, which are not uncommon things to see. Um, I do think would be helpful to address to everybody just because these are really good questions that are being asked. So let's go ahead and take a look at some of the requirements that I'm asking you for the Aquapod launcher, which are really the same requirements that I'm asking for the family game night. So first thing, I did ask you for the initial velocity in both components, and I asked you for the total velocity. This is what you're also looking at when you do the family game night. So for the family game night, you were told to figure out the optimum angle and the optimal total velocity in order to be successful in your sport. So I'm going to go ahead and make myself bigger. So when I ask you for total velocity, one thing to remember is that when we think of our velocity triangle, there are three pieces to that triangle. You have your horizontal piece, which is your VIX, your vertical, which is your VIY, and then your hypotenuse, that's the total. So one of the things that I've been seeing is people will solve for one single of those pieces and will stop. But those pieces have their own specific meaning. One of the velocities is just for the X component. One of the velocities is just pushing the object upward. But the total velocity is bringing those two pieces together. That is like the maximum that you are applying. That's the total that you have. So that's really what you're solving for. You don't want to just stop when you get a piece of the puzzle. You want to stop when you actually get to that hypotenuse. So one of the things that's been happening, especially with the Aquapod launcher, is the use of trig functions a little bit too much. Now, I say that, and you may be thinking, well, in math class, like I can use that whenever I want. And it is true. Mathematically, sure, you can use sine, cosine, or tangent whenever you have the pieces. The problem, though, is with physics and with some of these questions that we're doing now, we did have to estimate some of our numbers. Now, I estimated to the best of my ability. I took the measurements to the best of my ability, and you will do the same. But unfortunately, sometimes with a shoe or just trying to get an angle off of Hudl, we don't always have 100% R squared values of 1. And if you use trig functions over and over again, you tend to compound little measurement errors and they become much bigger ones. So for instance, with the Aquapod launcher, you know a lot of information right off the get-go in order to solve for VIX. Well, having that allows you to solve for tangent, which tangent gives you VIY, and then you could also use cosine in order to find the hypotenuse. And you just now did two more calculations using the exact same number that you calculated off of an estimate. So now that small estimate becomes bigger and becomes bigger and becomes bigger. And now we start to get numbers that are a little off from what they should be. So when you do these problems, the family game night and the Aquapod, your main path that you should be taking is the physics equations. Yes, using trig in order to solve for variables is one path. Using the physics equations is another. Using the physics equations will give you more accurate answers. So use our physics equations, use the given versus known charts to solve for VIX. You can then solve for VIY. And then if you have A, B, and your hypotenuse is C, well, A squared plus B squared equals C squared. We can use Pythagorean theorem. And that is what I have found to be a little bit more of an accurate answer because that doesn't rely on that angle again. Yes, it does rely on your calculations for VIX and VIY, but you did those using the physics equations rather than just trying to use a whole bunch of estimates. So if you're looking at your paper and you're right now saying, I don't think my numbers look right, it may be because you use trig a little bit too much. So go ahead and look at what you've done. And if you haven't used the physics equations in order to solve for VIX and VIY, go ahead and do that. Then you'll start to see answers that make a little bit more sense. Now, one thing to to remember is that at least for the aquapod, this was a perfect parabola. So knowing that it's a perfect parabola allows us to do a lot with maximum height. It allows us to do a lot with saying, okay, this is symmetrical. What does this mean? What can I do with that? So kind of just keep that in the back of your mind as you're going through these problems. Same thing with the family game night, if it's applicable, but the family game night is still asking you to solve for that total velocity. So make sure that you're solving for that hypotenuse in the end. All right, I think that's all I had to say on this. I will be responding to some of the emails that came in last evening. And if you have any questions as you're going through today, feel free to ask. All right, have a good 3-day weekend. Make sure that you have everything done and ready to go, though, for Monday in order to turn in. However, if you are ready today, the practice quiz turn-in has already been uploaded, and you could also email me those mixed scenarios if you would like to kind of get a jump on that. But you'll see probably tomorrow I'll put the assignments in for Monday. I just didn't want to kind of like inundate you with a whole bunch of assignments or assignment turn-ins at one time. So just kind of be looking at the playlist, and then the playlist for next week will come out within a couple days. All right, have a good weekend. Bye-bye.